Hello everyone, my name is Kjell Alving and I'm a professor of respiratory pharmacology at Uppsala University, Department of Women's and Children's Health. So I've been working on asthma, inflammatory mechanisms and biomarkers since the 1980s, and in the early 1990s we were first to show elevated levels of nitric oxide in exhaled breath in asthmatics. And after that, a development followed with starting of companies, the Aerocrine company during the 90s, which later turned into Circassia and is now NIOX Group. So I've been working on this methodology since the early 90s, both when it comes to developing a standardized method and the clinical use, but also instruments. So I've been deeply involved in the development of the first chemoluminescence based instruments, NIOX and NIOX Flex, and later on the electrochemical sensor based instruments, NIOX MINO and NIOX VERO, the presently used instrument. Potassium permanganate is an oxidizing agent, and it will oxidize nitric oxide to higher nitrogen oxides that are non-volatile, and they will stay in the scrubber. So nitric oxide will be very effectively scrubbed away from the air that passes through it, giving really nitric oxide free air on the other end, so to say. In the NIOX VERO, there is a flow regulator, a mechanical flow regulator that helps the patient to keep the required exhalation flow rate to 50 mL per sec. This flow regulator works fine if the oral pressure is between a certain range, in this case 10 to 20 centimeters of water. And the pressure is, the patient is informed about the oral pressure via the visual feedback, the video on the instrument, and there is also a sounding alert. So it's very easy for the patient to see the development of the oral pressure during the exhalation and to keep it within this range. The NIOX sensors, they are factory calibrated to start with. This is important since it's very difficult to keep and to correctly use a calibration gas. It's very easy to get contamination with oxygen into the nitric oxide cylinder, and in some places there has been a lot of problems with using the calibration gas past the expiry date, which will of course be a problem when you calibrate. And the sensors, they are given a limited time of use, so that there is a strict expiry date of the sensors, and the functioning of the sensor is guaranteed during this time. And not only the active time is recognized, but also shelf life before that. And the sensor, the NIOX instrument measures environmental conditions like humidity, temperature, and pressure. And changes in these environmental conditions are then accounted for in the sensor, so there are corrections done so that the sensor will give a correct value in spite of these changes in atmospheric conditions. There is also a zeroing, so that there is a regularly feeding of nitric oxide free air to the sensor to do a zeroing of the sensor. So there is a small scrubber also inside the instrument. I would say it's really easy to use. I've been around since the 1990s, where we built our own systems with pieces from anesthesiology, more or less, tubes and non-rebreathing valves and all that. So there's been a tremendous development, and NIOX VERO, with the built-in flow regulator and the very neat visual feedback and the comfortable handle, makes the instrument very easy to use for the patient. And we have seen that at least when reducing the exhalation time, which is possible in small children, quite small children are able to perform a measurement down to the age of 4 for certain individuals. And I think that's good proof of the instrument being very user-friendly. Well, the NIOX should always be used with the single-use mouthpiece, which is also a sterile filter, a highly effective sterile filter that filters away basically all microbial contaminants, both bacteria and viruses. And this means that cross-contamination is really it's not a high risk. It's a very low risk with the cross-contamination. Compared to spirometry, when you exhale, maximally, there are more particles or aerosols are formed. An exhalation at a flow rate of 50 mL per sec is quite a slow exhalation, basically. So during this procedure, there's a very low generation of aerosol particles. Well, again, it's because the sensors, which is actually the measuring unit in the NIOX VERO, they are factory calibrated, and they have a specified work life with a deadline, an expiry date, and the factory calibration is guaranteed during the work life of the sensor.